Okay, so what we're going to need to do with polynomials is factor them as the product of linear factors. What does that mean? Well, just like we factored quadratic polynomials, so let me refresh your memory. If I gave you this function, x squared plus 3x plus 2, and I said factor, you would say, I meant to say 2, you would say 2 numbers that multiply together to give me 2, and add together to give me 3 would be 2 and 1. And that was one way we learned how to factor. It's kind of the opposite of FOILing. So what did I do? I just wrote my quadratic polynomial as the product of linear factors. In this case, just two linear factors. And you might remember that's very useful for us because now we know what the x-intercepts are, or the zeros, right? We would set each linear factor to 0 and solve, and that really helped us with the function, understanding the function, because we would get our two x-intercepts. We're doing the same thing here. The only problem is our polynomial function is a little bit more complicated. If I jump down here to example 4, it's not that easy, and that's why we have to do the long or synthetic division. All right, so let's try this one, example 4. I want to write this as the product of linear factors. I gave you a hint here, so we're just warming up, that this is one of them. So that means I'm going to be able to write this polynomial function as x minus 3 times something else. What's the something else? Well, if we were to factor a linear out of a cubic, we should get a quadratic. Okay, I don't know what it is yet. We're going to have to find A, B, and C using the long and synthetic division. But the idea is if I have a cubic and I factor it with one part of the product or one factor being linear, then I should end up with a quadratic. And then this I don't need to use long or synthetic division for anymore because I know how to deal with quadratics. All right, so let's give it a try. If I did long, it looked like this. And if I did synthetic, it looks like this. It's going to give me the same result. So let's start with the long, and I won't do long much more. I want to show you that it works, with the synthetic division works. This will probably be the last example I do of long division because I prefer synthetic. But let's just do one more. X goes into x cubed, x squared times, multiply, x cubed minus 3x squared, subtract, negative 6 minus negative 3 is negative 3x squared, bring down the 11x. X goes into negative 3x squared, negative 3x times, multiply, negative 3x squared plus 9x, subtract the whole thing. Remember, that should give me 11 minus 9x, which is 2x. Bring down the 6. X goes into 2x 2 times. 2 times that expression is 2x minus 6. And we get remainder 0, and that's good. This x minus 3 indeed was a factor because it went in evenly. So I now know my polynomial can be written as x minus 3 times the result of my factorization, which we call the quotient, this thing. X squared minus 3x minus 3x plus 2. All right, and then I can deal with this because I know how to deal with that. I can factor that in a second using not the long division or synthetic division, but the old methods of factoring quadratics. Okay, let's just verify that answer with my synthetic. Bring down the 1, multiply, add, multiply, add, multiply, add. Oh, that was a lot easier. We just have to understand this represents x minus 3, and this is a quadratic because I started with a cubic. Okay, I like the synthetic. Isn't that a lot easier? All right, good. So now the goal is to write this as the product of linear factors. So that's equal to x minus 3 we got. That was given. That was a hint. And we got this quadratic, and now I remember how to factor quadratics. Two numbers that multiply together to give me 2. And add together to give me negative 3 should be negative 2 and negative 1. And this polynomial is written as the product of linear factors, which is that. And now you can see where we're going with this. If I ask you to graph this thing, I know what the 3 x-intercepts are, 3, 2, and 1. All right, how about this one? In this case, I don't give you any hints, right? So we need somewhere to start with. So what I'm going to do is jump ahead because I need somewhere to start. So I'm just going to jump ahead in my notes and I'll come back, and it's called the rational root theorem. So if you're given this polynomial function, then all of your possible rational roots will be written as the factors of the last term, p, this guy, divided by factors of your first term, q. Okay, so that means any potential rationals there, just the rationals, I can get from dividing the last number by the first number. So let's go back to this one and try and employ that. So my possible rational zeros are all my factors of 4 plus or minus 1 plus or minus 2 plus or minus 4. Those are all the factors of this number. And this is an easier one because that's just a 1. So if I divide by plus or minus 1, that doesn't change anything up top. So it's just going to be plus or minus 1 plus or minus 2 plus or minus 4. Okay, so I got 6 potential rational zeros. So I have to do a little trial and error. So let's try 1. And this is why I really like synthetic division. 1, -6, 13, -12, 4. And I'm seeing if it is. I don't know if it is. All right, I'm testing using synthetic division. Bring down the 1. Add. Multiply. Add. 8. Multiply. Add. I got lucky. All right, I just picked 1 and I got lucky, so I got a 0 remainder. Okay, so I like to just go step by step. What did we learn here? Well, I divided by x minus 1, right? This is the 0 that goes with it. And I divided by a 4th degree, so I got a cubic, x cubed minus 5x squared minus 5x squared plus 8x minus 4. That's this 4th degree polynomial factored. But I still have a cubic. So now I have to divide again. So let's see what happens. I gotta do the synthetic division again. So I'm going to put these coefficients, 1, -5, 8, and -4, and see if I can't find another factor. So what do you want to try? So we know that 1 was a factor. So maybe -1 is. Let's try it. 1, -1, add -6. Multiply 6, add 14. This one's not going to work. All right, I get a remainder. So no good, right? -1 is not a factor. So I've considered both of those guys. So now I got to try again. All right, it's a lot of trial and error. So that's why these are more complicated to factor, much more complicated than quadratics. What do you want to try? Let's see. Let's just try 2 and just make my way up until I find it. I'm going to try 2. Does 2 factor? 1, 2, add, multiply, add, multiply, add. And we got lucky. We got a factor of x minus 2. Okay, so this is the x squared, this is the x term, and that's the constant term. So I know x minus 1 is a factor. I know x minus 2 is a factor. And here's my quadratic that remains, x squared minus 3x plus 2. And I can factor that the old method. X minus 1, x minus 2, x squared minus 3x. Whoops. I said factor. Let's factor it. Two numbers that multiply together to give me positive 2 and add together to give me -3. We saw this one earlier. X minus 2, x minus 3. Wait a minute. We got a repeated 0 here, so I can simplify this solution a little bit. That's x minus 2 times x minus 2 is x minus 2 squared times x minus 1 times x minus 3. That is the same function as my original function, that guy, in factored form, the product of three linear factors.